geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A tube with both ends open to atmosphere is partially filled with water, oil, which is immiscible with water. That means water and oil are taken in a U tube, but oil and water are not mixing. That is the meaning of immiscible. Immiscible means both are not mixing. Is poured into one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level, then density of the oil is. Look at the diagram. Oil is there in the left side of the U tube and water is there right side of the U tube. And at the free surface, pressure remains same, of course, as long as the liquid is at stationary condition or rest condition. Pressure remains same at all points according to Pascal's law. Since the oil in the left limb of the U tube and water in the right limb of the U tube are at stationary condition, therefore the pressure of the oil at its free surface equal to pressure of the water at its free surface. Oil free surface is at A, whereas water free surface at E. That means pressure of the oil, pressure of the oil at A equal to pressure of the oil. Let me write it clearly. Pressure of the oil at A, pressure of the oil at A equal to pressure of water at E, at surface of water E. Pressure of the oil at A equal to rho of oil, G into H of oil equal to pressure of water at E equal to rho of water G into H of water. Here G part is cancelling, then it can be written as rho of oil into H of oil equal to rho of water into H of water. Now look at the height of oil with respect to bottom. With respect to bottom, this is the height of the oil. This height of the oil, this height of the oil equal to 65 plus 65 plus 10. 65 plus 65 plus 10 equal to 140 mm. Let me write it clearly. 140. H of the oil, H of the oil equal to 65 plus 65 plus 10 is equal to 140 millimeter. Whereas this is the, look at the screen. This is the height of the water. This is the height of the water. Look at the screen. The height of the water is 65 plus 65. It is equal to 130 mm. 130 mm. Then you are asked to decide density of the oil. From this density of the oil equal to density of the water into H of the water divided by height of the oil. Here density of the water is given 1000. Let us take another slide. Here density of the oil equal to density of the water, density of the water into height of the water divided by height of the oil, divided by height of the oil. Density of the water is 1000. Height of the water, look at the height of the water, 130. Height of the oil, 140. 130 divided by 140. You simplify it. You simplify it for getting 928. Simplify it for getting 928 kg per meter cube. That is the density of the oil, which is present in the left limb. 928. Option D is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. It is asking like this. A rectangular film of liquid is extended or expanded from 4 centimeter, 2 centimeter to 5 centimeter, 4 centimeter. That means initial area, I can say, because it is a rectangular one, breadth multiplied depth. 4 into 2, it is equal to 8 centimeter square. It is equal to 8 into 10 power minus 4 meter square. Similarly, final area, because it is expanded or extended, 5 into 4, 5 into 4, that is 20 centimeter square, that is equal to 20 into 10 power minus 4 meter square. If the work done is given 3 into 10 power minus 4 joules, the value of surface tension of the liquid, you are asked to decide what is the surface tension sigma. Okay, for that, as we all know, work done equal to 2 times the surface tension into final area minus initial area. From this, the surface tension equal to work done by 2 times the final area minus initial area. It is equal to work done. Look at the work done. Work done is 3 into 10 power minus 4 divided by 2 into final area 8, final area 20. 1 minute. It can be written like this: 20 minus 8 into 10 power minus 4. This 10 power minus 4 is cancelling. Here it is equal to 3 by 2 into 12. It is 3, 4 times. It is 1 by 8. 1 by 8 equal to 0.125 Newton per meter. 0.125 Newton per meter. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Asking like this. 3 liquids of densities rho 1, rho 2 and rho 3. Given that 3 liquids density relation, rho 1 is given more than rho 2 is given more than rho 3, having the same value of surface tension. That means sigma 1 equal to sigma 2 equal to sigma 3. Surface tension remains same. Of course, it is given as T, or I can say T1 equal to T2 equal to T3. Remember, surface tension can be denoted either with sigma or T. Rise to the same height in 3 identical tubes. In 3 identical tubes means diameter of the tube 1 equal to diameter of the tube 2 equal to diameter of the tube 3, or radius of the tube 1 equal to radius of the tube 2 equal to radius of the tube 3. And rising to same height means h1 equal to h2 equal to h3. Okay, as you know, the capillary height, the capillary height h equal to 4 sigma cos theta by rho gd in terms of diameter. Of course, it can be also written as, 4 sigma cos theta by rho into g into d equal to 2r. It can be also written as 2 sigma cos theta by rho g r, because diameter d equal to twice the radius. Okay, then let's see what you are asked to find. The angles of contact theta 1, theta 2, theta 3. For the relation between the theta angle of contact for the three fluids. Now from this, h remains same. H is constant. H is constant. Given sigma is constant, and no g constant, radius constant. Then I can say that rho is proportional to cos theta. Rho is proportional to cos theta. Then when theta is less, if theta is decreasing, rho value increases. Given that, given that rho 1, look at the given relation, rho 1 more than rho 2, rho 1 more than rho 2, more than rho 3. Therefore, theta 1 less than theta 2, less than theta 3, but it must be less than 90 degrees. That is pi by 2, but it must be more than or equal to, 0, 0 degrees. Okay, that is the relation. So theta 1 less than theta 2 less than theta 3 less than pi by 2. Look at the options. Look at the options. Theta 1 less than theta 2 less than theta 3 less than pi by 2. But theta 1 is greater than or equal to 0. Option B is absolutely correct. Okay, it is the most important problem. That's why I'm writing 5-star problem. That means this kind of problem can be repeated. Understood clearly? Yes. Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Water rises to a height h in capillary tube if the length of capillary tube above the water surface is made less than h. Dear friends, remember, even if the height of the capillary tube above the water surface is decreasing by height h, remember, water can be rising up to the top of the capillary tube and stays there without overflowing. Therefore, option A itself is absolutely correct. That means even if the height of the capillary tube above the water surface is decreasing, water cannot be overflowing. Therefore, option A is absolutely correct. Okay.
Geobyte.